All right, how's everybody doing? All right, schema storming, code-first implementation, interesting stuff. But I wanted to start by just recognizing the journey that GraphQL has taken all of us on. And I think that it starts with a desire to solve problems. I mean, that's what we're doing. We have the emergence of this new technology that allows for these amazingly personalized experiences. We have these computers in our pockets that literally are used to take an entire room, and it couldn't even do that. I just got a notification on my phone that my dishwasher is done in Portland, Maine, and the idea that that can happen is pretty remarkable. Like 20 years ago, that would have been magic. So I'm happy to be here with all of you, and it's some of the smartest people I've ever met, some of the most complex and hard to reason about conversations about what we're doing here to unify experiences and ultimately facilitate communication, to bring business value, but to make people's lives better. So that's me. The clicker doesn't work, but that's interesting. All right, so yeah, I work for Xolvio. We work with some pretty large graphs. We help people get on the graph, and we help people really understand what that platform journey is for the GraphQL in their organization. And I work for the Wayfair GraphQL platform team for the last year and a half, and the exposure to scale there has been just so valuable to understand how this stuff is wired together. Some really amazing people at Wayfair I've learned a lot from. So it's really, really great to be here. I think we help businesses, but more than that, we help people. We're all people trying to do the best job we can given the tools that we have. And GraphQL is simply another tool in the toolkit, so we have to use it properly. We have to use it at the right place at the right time. And Federation and the platform provided by Apollo really enables the time to value for GraphQL to be very, very quick. And we're here today to talk about a strategy to maybe unify this question of schema first versus code first. So there's a lot of discussion around how we should design schema and who should be in the room. And then when we have that schema, how do we build the code to fulfill the contract? So the developers in the room, a lot of them, and a lot of the developers that I've talked to are very interested in code first because it allows us to do what we like to do, which is write elegant classes to represent data structures, to have inroads to business logic and rules. And the result of those classes is the SDL, it is the contract. Now, you can't really have a meeting with a product owner about your annotated class. It's very hard. The schema is the language. It is the ubiquitous language, you could say, of what we call things and what the shape of things should be in our business, really. And so the schema first allows you to design and have that implementation agnostic place in the GraphQL spec to have these conversations. So you're not talking about a specific language, but we get to talk about the spec. And so, but what we've found is that we have a technique that I promise you when you leave here today, you're gonna have some new ideas about how we can actually get our code first resolvers and get our schema first too. So let's dive into schema storming. Schema storming, so think brainstorming, but with schema. So, but before I really dive into that, last year, a colleague of mine, Ryan Marsh, gave a talk on event storming. So who has heard of event storming or done any event storming? Event storming is really cool. Essentially, the assumption is that all of your business processes for your customer can be told in a form of a story. You got an email that there's a sale. You then go to the website, you search the website. Oh, I picked the item on the sale. I put it in my cart, I take it out of my cart. I say, I don't want to buy it online, I want to go see it in the store. So what you as the business do in relation to the customer changes depending on where they are at in the story. What chapter are they in? Are they in the cover of the book, or are they in the index, or are they in the climax of the story, which is the moment where they're about to buy the thing, and how do you entice them to buy the thing? So if you start to see these pivotal events, then you can start to see the boundaries of your domains. They sort of emerge, and so then you can start to apply that to code decisions, team decisions, and so on. So that's event storming in a nutshell. We do a lot of work for a lot of different people. We solve a lot of different types of problems. So what we're realizing is that there's a lot of conversation about how do we facilitate visually when you have a design. How do you tell the coders what to code, and how do you maintain some sort of accountability to that original design? This is an interesting problem that is a more recent problem, actually, because in years past, it all came from the server. And then the SPA and everything on the front end took over. And now we're in this situation where we want these decoupled experiences. So now we have to bring those teams that were working far distant from each other in the organization into the same room to talk about the contract, the GraphQL. And so what we're doing with schema storming is we're visualizing this schema design with pretty simple UI annotation, but it has meaning. And we believe if you consistently annotate UIs across your organization, then you save time because you can go from one team to another, and it's the same type of conversation, it's the same type of diagram. So we have a technique to apply to a whole view or a given user journey in that view. And it's probably more efficient to apply it to a user journey, but we're gonna dive in and apply it to a whole view here. So we separate it into 3 steps. We define the ubiquitous language, which is, let's agree on what we call stuff. Naming is the hardest part of software engineering. Naming is probably the hardest part of your business. What do we call it? And so if we can agree that we call the thing, then we don't have to change code later when someone says, well, it's actually not called that. So once we have that language, we can begin to design this entity model around it and power the experience components, the actual user interface that we are trying to present to our customers. So let's check it out. I move my mouse out of the way. We have this view, the Xolvio swag shop. We got our sweatshirts and our t-shirts and the really cool stuff. So we're gonna launch this website. It's a pretty simple view. We have a user journey that we wanna add to that view, which is like reviews. We want users to be able to see reviews on the shop, right? Pretty simple stuff, but it provides a great starting point for an example of how to apply schema storming. So step 1, define the ubiquitous language. Well, really easy. It's taken from the event storming, the methodology of get the right stakeholders in the room, get some sticky notes out, and start putting them on the thing. Item count, URL, title, easy stuff, right? So you keep it simple so we can agree on what we call stuff. Once that's done, you take it one step further and you start to look at the entities, look at the types involved. And I think that the same people can still be in the room because it's important that we call a product and options that are options. And so if we can agree on these kind of one level up names, then it helps us. So we annotate those with the dependencies kind of mapped out on the UI. Next, we're talking about experiences. We're talking about components, reusable front-end components. We have so much talk about server-driven UI and the ability for the mobile app to update on the fly when we push out a new server-driven component. So we are supporting that model, which is very effective, by simply annotating the boundaries of these component areas. And so we go down and we do that. We understand that it's a product detail, it's a similar products, a subscribe bar. We've all seen diagrams like this, but if we can agree on how we make them, then maybe we can save some time. So, take away the site. what does it start to look like? I mean, we're here, we're trying to think in graphs. Well, it makes it pretty easy to think in a graph when you're essentially building a graph. Now at this point, the people who are involved in the design can leave the room. And now you can take this back to your developers, and you start to see that if you direct this graph, what emerges? An entry point, return types from that entry point. We have type nodes and field nodes, and the next obvious thing that emerges from that is a query. And the nice thing about this pattern is it allows for this query to be separated into fragments. Those fragments can be defined and worked on in separate areas, and we know exactly where we need to go if we need to change something. It all goes to power this query on the right. So what does that look like? We have this UI components decoupled. The demand, we've heard a lot of talk at the summit about supply and demand-oriented design. Well, this is what ends up happening in a decoupled ecosystem, is that you have a decoupled demand that is supplied by these subgraphs, which enable us to decouple along the domain boundaries where the data is. So what emerges there is teams. So what we're talking about here is people. We're talking about who works on what, and let's not keep repeating the same work across the organization. And if someone's already done the work, can we use it? Can we put it in a place where more than us can use it? I really enjoyed what Bruce was saying about the fact that the experiences at some point just start happening unbeknownst to the platform team. That it's so good that people can create new user experiences and hydrate them, and new teams can emerge and new people can be hired, all because you've set up a great system that's going to ensure that the contract between the client and the server is met. The type safety between the client and the server is just remarkable. Like it is an amazing thing to think about. So now let's take that user journey. Let's look at what that looks like. So we have this new reviews component. So now we have a problem, right? We've already annotated our whole page, and let's say we've gotten it into production. So now we have this idea of we want to add stuff to it. So we came up with a way to add stuff to the diagram. Wrap it in green. If there's a new subcomponent, annotate that too. There's many different ways to do this. This is the way that we've come up with. So we start the journey again. So let's look at how this pans out. So in that reviews component, everything's net new. This is all new data fields, new entity types. So we've updated our legend to show that we have these new colors. Dark green is new. A dotted line is a new child relationship. But the cool thing about this is that we can start to see where we need to put stuff. And it is a simple task to add this, but it becomes even simpler when you know exactly what existing types need to be annotated in your graph to hydrate the new demand. So you can see down here that it does get a little complicated. If you could take away the old stuff that already exists, then you can sort of see exactly what you need to add to the thing. And so this enables us to split the work up into small, achievable pieces. And again, before we write a line of code, we want to agree on what we're calling things and where it should go, and ultimately who should work on it. So here's this new reviews component ready for action. So if we apply the same direction to that graph, we can see that now what results is a change set to the original query. And so we can do the same thing that we did before. We can split that up along UI component fragments, and it'll add a new field to our central query, our experience query. And so again, we've taken the front-end demand and the back-end supply, and we have this perfectly updated query. So, this could seem like a complicated strategy for what at face value is a pretty simple task, right? Make a little product page and put a reviews component in it. But if you have to do this 4 times or 20 times or 100 times or 1,000 times, you see that if you have a pattern, if you have a standard by which you agree on how you arrive at the new schema, you will probably save time in the long run. So again, what emerges from that is these teams, these front-end teams, back-end teams, and a platform team in the middle to provide the governance, to provide the developer experience and acceleration to actually make all this happen within your organization and within your constraints. And so I want to talk a little bit about legacy. Again, we're not saying that GraphQL is going to solve all your problems. It essentially allows the legacy parts of your system to exist alongside your new experiences that you're creating. And there's so many examples of this happening at scale. Some companies decide to shift all their BFFs onto the graph and then go, because you get observability out of the box, you get there actually is benefits to that pattern, and it has worked for certain organizations. The other side of that spectrum is don't put anything on my graph, It needs to be perfect before it enters the ecosystem because I don't want to be the one to have to go fix it. I think that what we're dealing with here ultimately is a communication problem. The technology exists. Now we have to figure out how to listen to the needs, but we have the opportunity to put the demand first. That's what keeps emerging here. It's not anymore that you'll get what I can give you from the API, and if you need a new REST endpoint, that's going to be X amount of dollars, X amount of time, and you probably don't want to do that. To now we've created an intelligent organization of types and fields, and with the power of Federation 2, we have all these interesting ways to cross these boundaries and for a single team to federate on a single field, completely decoupled from the rest of the environment. So it's powering these new experiences that we're seeing, these personalized experiences that a lot of you in the room are working on. So we have that query. So we were talking about Schema-first to code-first. But first, I want to say that at Xolvio, and we've been working on some internal tooling to sort of keep track of this diagram, right? So there's so many opportunities to, you build it in Miro, and Miro goes out of date. And you build it in Miro, you export a PDF, put it on a slide deck, and then say, don't look at the Miro, look at the slide deck. Or it's in Google Docs, or it's in my email, or it's in Slack. So there's so many ways we can lose track of the decisions that we made around the new experience and the schema that results. So over here is our tool. And so we have the same experience that, a Miro-like experience, but instead of it being on one page and only being on that page, we actually connect this to a back end, and we have a way to connect it to docs and to specs, and have a single place to go back and look at what we did and annotate our changes to that. So code first. How does this relate to code first? Well, the output of the schema storm is schema. And the schema provides the contract that your service now needs to fulfill. So we at Xolvio love test-driven development. I mean, I love the idea that I have really good test coverage, and if I need to muck around in that little feature or add a new thing, if my tests are passing, I have so much confidence that my deploy isn't going to blow up. So how can we apply some of these hard-won concepts to schema design? So let's look at what needs to change here. So we have this new reviews team that formed, and we have we ultimately have this. In our account subgraph, we're now going to federate on whether or not a product is liked. So it's a pretty simple ask, right? Well, let's look at how code-first can help us here. So there's a lot of code-first libraries out there, actually. And for most of the major languages, definitely GraphQL Kotlin is an amazing library. And we use a library called type GraphQL. I don't know if people have used type GraphQL, but it's really fun. So let's show you how that pans out. So can we see that? So here we are. I use a tool called Wallaby, which is a great tool that kind of shows me if my tests are passing or failing in a live fashion. So here we are. With code-first resolvers, we have the ability to assert whether or not our service is outputting the correct schema in sort of an integration test. Now, when your schema is small, this might make sense. When it gets large, it wouldn't necessarily make sense to assert this large string against the change string. But I'm just showing this to illustrate the power of what code-first classes and resolvers can do. But let's check out what it looks like. So if you see, it's very clean. I like it. It's an object type. It has a directive. It has a field with a type that it returns. And then the native type. So it's an ID, but it's a string, right? All that's done right there. It's easy to reason about, and that's why I like it, because I think the time to value for developers to use code first is quicker. You're not looking at type defs and resolvers. I mean, you kind of are, but you don't have to start there. You can start here with what you're used to, which is a class. And this uses like the reflect metadata and stuff. Some cool features of TypeScript are at work here to allow those directives to work. So this wasn't even possible a few years ago. So this is our code first class. It's just a class. It's a user class. OK, so now let's see what happens when we want to add that product type. So we have this. Whoops. So we commented this out. We'll uncomment it. And now we have an instantly failing test, right? So how many of you have seen schema pushed with no resolvers to production? Anybody? Well, we've seen it happen at scale, and it isn't pretty. There's nothing protecting you in a distributed microservice environment from a service pushing schema to your router without any resolvers backing it. And there's actually interesting ways that you can run your subgraph with no resolvers, yet it can still be introspected against. So this protects against that bad experience at scale. So now we have a failing test that we have to go fulfill. So let's go make the product class and the product resolver. So here we go. It's preloaded for me. And of course, nothing's working. So we have it now. It's very simple, right? We have this federated product type. We have an ID field, and we go off to our data source to get whether or not it's liked. Now, I agree this is a very simplified example, but you can start to see the power of this pattern, which is your resolver is in your field. That's pretty cool, that you can begin to write the resolver right there. It is an easier way, in my opinion, to reckon about all this stuff. And of course, as you apply patterns of scale, you need to solve other problems. But this is the simple example of how easy it is to begin writing resolvers and begin getting schema to be backed by type-safe code. So now we'll go back over to our test. But in this time, we now have the opportunity to unit test our field resolvers in a really specific fashion. So what's cool about this pattern is that test is failing. And I don't know why. I'm not sure why that's failing. Oh, again, this is the problem, is that one's out of order. So, because I have to add this. One sec. Coding, live coding. So we do have to add this to an orphan types area because it's a federated type. It doesn't actually have a query entry point into this graph. So we go back to this test, and we can see that we have the opportunity to assert whether or not it satisfies the SDL contract. So again, we can have a type level test that says, does your service output the correct schema? There's a win there. Now we can go and look at the fields. It should have an ID field. Did they put an ID field on the class? Well, that would be good to make sure that that happened. Does the liked field call the data source? Is it implemented with a resolver? These are really simple things and they look really obvious, but when you're dealing with, like Wayfair has almost 100 subgraphs and 3,000 types and 10,000 fields. So you can imagine that little mistakes have real implications at planet scale, and I would say they have implications at farm scale too, and I can attest to that. So, but now we have these kind of clean assertions here, and that is something that gives you confidence in your deployment when you're adding a field, and this easily could start to be generated. Like what I would like to have discussions about is, and I've had a talk with a few people in the room who face these problems, is test gen. Like we have a schema, why not generate the tests immediately to have an insertion point for you to test your resolvers in your fields. So, but again, so that we have, we are hearing that these problems exist. So also, and that internal tool I was talking about, or the tool that we're building for subgraphs, is we have this ability to show, and I could show this again. So we have this demand, decoupled demand, a perfect query, and the decoupled supply. Well, let's look at this. So now we actually have a place where we can go and we can put these queries in. These are fragments, right? And so we can check this out. We can see our product fragment. We can actually go over here. We can see our experience query. And so all of this stuff that normally just lives in Miro and dies in Miro has a place to live forever, right? This is connected. And we have mechanisms to detect changes on it and talk about those changes. So, and now not only that, we have the subgraphs. We have the very places that need to go make the changes. And again, this is long-lived files that represent that schema. So now you have the ability to work on your schema in a place where when you come back, you know that you can collaboratively edit it together. And so then if we dive in here to the products graph, we have some places where you can insert specifications and even define the databases that you're connecting to, and even database queries. And so this product has come out of the need, seeing this done in a myriad of ways and not necessarily knowing where to go back and find it. So, so if we check out these specs, well, look what we have here. We have that product entity should do those things. And so this spec can live in your UI mockup tool and in your code. And we're trying to develop ways to maintain parity and like branch-based work on this type of stuff. So that is something that we're really excited about. It solves the specific problem that we're talking about. So many people are talking about this problem. And so we believe that it's going to bring some real value to the discussion here. So, yeah, you can, sorry, I just want to get to the next slide. So you want to scan that, share your feedback. I'm really stoked to be on stage and talking to everybody. It's been a great, I've learned more in like 2 days than I have in the last 2 months. Like, it is very easy to learn fast, and in our industry, we have to learn fast. You have to stay relevant, and I feel like Apollo and this summit is an opportunity for all of us to stay relevant. So one thing I wanted to show you is that tool we're building. We had this assumption that it's great to write all this by hand, but what if like AI could just build it all for you? So let's see. Like, what if AI could build those queries for you? Let's try it. So let's make a Twitter clone. Let's see what it does. Those are queries. And they're pretty good. So by limiting the scope of what you ask the AI to do, what we're talking about here is limiting the scope of what we're asking humans to do. If it's easier to work on a small task, so AI is the same. Ask the AI to do something simple, but not only does it build the queries, it actually builds the rest of the system too. So we're working on some really fun stuff. If you want to learn more, come to our topic table. That's all I got.